Right, log function manipulation. We need to use properties of log to write these as single log. So here we're going to use the sum property of log, which says that log a plus log b, given the base is same as log of a times b. So since the base is same, the base is 3, so this will be the log with base 3 of the two guys are multiplied together, and I cannot really multiply 4 and z, so I will just write 4z. Likewise, if they are in subtraction, however, rather than multiplying, I will divide both of them. So since the base is same, both are natural log, so natural log of a over b or x over w. Here we need to do the same thing two times. So first is log a minus log b property over here, which is log of a over b. The base is 10, so this will be 3 over x minus log of 5 with base 10, and then log a minus log b once again, so log of a over b. Here we need to be careful. A is already a fraction, 3 over x over 5, so it's a multi-level fraction. We can use keep change flip, so we can write it as 3 over x divided by 5. And if we use keep change flip, let me make some space here. If we use keep change flip, then I will say that I will keep the first thing, change the sign, and flip the other guy. So finally, this is going to look like log with base 10 of 3 over 5x. This is the final answer. Right. All right. Okay, just boxed it. Same thing over here. So, but before doing that, we need to first apply another property because this 3 outside is creating a problem. I cannot really add these two just like that. So I need to bring this 3 on the power. So this is going to look like log of 6 with base 4 plus using the property, this will jump on the power of x. So x cubed with base of 4, and log a plus log b is log of a times b with the base 4. So this will be 6 times x cubed. This is going to be the answer. Here also I need to take care of these coefficients first. So this coefficient will jump on x, this 2 will jump on y, and this is as it is. Then I'm going to take these two, club these two. So log a plus log b is log of a times b. So x raised to 5 multiplied with y square minus ln w. Log a minus log b is log a over b. So ln a, which is x raised to 5 y square over b, which is w. So this is what we have here. And finally, same thing over here. I'm going to take care of these coefficients first. Right. So this is going to look like log of 2 raised to x minus log of x cubed minus log of y to the 1/2. I'm going to club these two first. So log a minus log b is log a over b. So log of a is 2 raised to x over b, which is x cubed, minus log of, can I write y raised to 1 over 2 as root y? That's the same thing, right? And log a minus log b is log a over b again. So this is 2 raised to x over x cubed. That's the first fraction over root y. So again, I'm going to use keep change flip. So this is eventually going to look like 2 raised to x over x cube multiplied with root y. So this is how we club this entire thing into one log. Okay. Here we need to do the exact opposite. We need to expand this log. So first off, it looks like log a over log b to me. Sorry, log of a over b to me, which is log of a over log of a minus log of b. So log of numerator, which is 3y to the 4, minus log of b, which is z square, and the base is same. I again see log of a times b formula here. So I'm going to apply that. I will make it log of 3 plus log of y to the 4 minus this thing remains as it is. And this is eventually going to look like log of 3 with base 5. 4 is going to be thrown outside. So 4 log of y, 4 log of y with the base of 5 minus 2 is thrown outside. Log of z with base 5 over here. Do we see any option like this? I think yes. It should be option C. That's a clear match. The same thing over here. In fact, it is the exact, it's a similar arrangement. So I'm going to write this as ln 5e square minus ln root x as log of a over b. So this is going to look like log of a times b is log a plus log of b minus ln root x. This is going to look like ln 5 plus 2 is thrown outside. So 2 ln e minus ln root x can be written as x raised to 1 over 2. Likewise, this is going to look like ln 5 plus 2 ln e, and this 1 over 2 is also thrown outside, so minus 1 over 2 ln x. All right, so do we see this anywhere? Okay, I think we can simplify this slightly more, because ln e is just 1. So this just becomes 2. So it will be 2 plus the other things remain as it is. 2 plus ln 5 minus 1 over 2 ln x. And this is definitely something that is in option A, right? So that's the answer. Right here, again, we need to condense these things. So first I'm going to take care of the coefficients, this, and this. So this is going to, these are going to jump on, the inside of the log. So it will become log x cubed minus log y square plus log of 16 raised to 1 over 2. So this will become log x cubed minus log y square. And 16 raised to 1 over 2 is just root of 16, right? And the root of 16 is 4. So this is log of 4. Okay, what is log a minus log b? Log of a over b. So log of x square minus y, sorry, x cube over y square plus log 4. And log a plus log b is log of a times b. So x square over y square times 4. So it looks like this is the answer, right? Because this is 4x cube on the top and y square at the bottom. So answer should be option C. Here we need to write the equivalent of log of x with base 5. We need to use a change of base formula. The change of base formula suggests that log of a with some base b can be written as log of a over log of b. So basically this was under the base of b. Now it is written with a base of 10, right? This is 10 and this is 10. So this will become log of x over log of 5, which is option C. Exact same thing over here. So this will become, I don't think so I even need to do this. So log of 7 over log of 3. Actually, yes, they tried to trick us in the formula, in the options here, because I don't see anything in the options like this, right? Log of 7 over log of 3. But like I said, the base can be anything. It's not mandatory that the base is 10. Here, if you notice, they have written this with a base of e. So this can also be written as ln 7 over ln 3, because the change of base means it's not compulsory that it should be written with a base of 10. It can be written with a base of e as well. That's totally fine. Okay, all right, so that's how it works. Which of the following is equivalent? Okay, what is f of w first off? F of w is going to be log of w with a base of 6 minus 3 times, what is f of z? Log of z with a base of 6. So this is going to look like log of w with a base of 6 minus log of z with base 6, and this 3 jumps on the power. And log a minus log b is again log of a over b, right? So log with base 6 remains as it is, and this becomes w over z cube as per the formula. So do we have that anywhere? I think yes, option B, right? Yeah, B should be the correct choice. Which of the following is correct? Okay, they are talking about transformations now. The transformations of logs are pretty interesting here. I can see that x is multiplied with 4. And whenever that happens, that x is getting multiplied with something, and in something that is greater than 1. So it's a horizontal dilation or horizontal shrink, to be precise. So I do see an option of horizontal dilation. And yes, this is actually a shrink, like I said, because horizontal dilations work counterintuitive. If you're multiplying with 4, that is actually a shrink by a factor of 1 over 4. So that is definitely a horizontal string by a factor of 1 over 4. Or dilation is just a general word, so option B makes absolute sense. That G is a horizontal dilation of F by a factor of 1 over 4. And finally, here we have, again, they're asking for the transformation. Here again, it looks like it's a horizontal dilation by a factor of 1 over 8, but be careful. There is no option with a factor of 1 over 8. So actually, it is not a horizontal dilation. At least K is not the horizontal dilation, right? Now look at graph B, option B carefully. H is a horizontal dilation of K by a factor of 8, which makes sense because if I'm going from H to K, that's a horizontal dilation with a factor of 1/8. Or if I'm going from K to H, it is a horizontal dilation with a factor of 8, right? Because if I want to convert ln 8x to ln x, I will multiply that thing. I will divide 8x with another 8. And when I divide by 1 over 8, or when I divide by 8, the factor becomes 8 for the horizontal dilation, right? Because like I said, it works counterintuitive. So H is definitely a horizontal dilation of K by a factor of 8. Option B makes sense.